Welcome, class. So today we are going to get into one of the most critical foundational principles in all of finance, and that is the time value of money. Now, I want to be very clear. This is not just some abstract theory you memorize for an exam. This is the core logic that drives virtually every major financial decision you will ever encounter in the business world, from deciding on a small business loan all the way up to a massive corporate merger. If you want to think like a true financial professional, mastering this concept is, without a doubt, your first and most important step. So here's our game plan for today. We're going to start by laying the groundwork, really digging into this fundamental principle of the time value of money. Once we're solid on that, we'll build on it to understand and value something called an annuity, which you'll see is just a structured stream of payments you'll find everywhere in business. From there, we're going to apply what we've learned. We'll step into a boardroom simulation and use these exact tools to make a realistic financial decision. And then finally, we'll wrap up with something incredibly important, looking at the common mistakes people make so you can be sure your analysis is always accurate and reliable. All right, let's dive right into our first section. I really want you to focus here because every single thing we talk about for the rest of this lecture, every formula, every calculation, every decision, it all stems from this one powerful idea. Frankly, if you don't grasp this, you can't succeed in finance. You're just guessing. This is the bedrock. Okay, let me ask you this question, and it might seem really simple on the surface. Of course you're going to take the money today, right? But the real question, the one a financial analyst asks, is why? What is the actual financial reasoning? Well, the answer comes down to two words: opportunity cost. That $10,000 you get today isn't just cash, it's capital. It can be put to work immediately. You could invest it, maybe earn a return in the market. You could put it in a savings account and earn interest. You could even use it to fund a small project. That potential to grow, that opportunity to generate more money, is completely lost if you have to wait a year. And because you lose that opportunity, the $10,000 you get in the future is fundamentally worth less to you today. And this brings us to the formal definition. This idea is called the time value of money, or TVM. It's a universal truth in finance. The value of money is completely tied to when you receive it. A dollar in your pocket right now holds a power that a dollar promised to you next year just doesn't have. And that power is its ability to grow, to earn interest, to be invested. This is exactly why we have to account for the timing of every single cash flow when we analyze any financial decision. So now that we've firmly established the why time matters for money, let's get into the how. How do we actually apply this principle? We're going to add a really important tool to our financial toolkit, one that lets us analyze very common financial situations. You see, in the real world, business deals are rarely just a single payment. Much more often, you're dealing with a whole series of payments over time. We have a specific name for this kind of cash flow pattern. It's called an annuity. And I promise you, once you know what to look for, you will see annuities everywhere. A company leasing its office space and paying rent every month, that's an annuity. A business that gets a licensing fee every quarter from a long-term contract, that's an annuity. Even things like bond payments, they all fit the definition, a series of equal payments made at regular intervals. Being able to put a precise value on these is an absolutely fundamental skill for any financial manager. So this creates a really interesting analytical problem, doesn't it? If we know that a dollar next year is worth less than a dollar today, we can't just add up all the future payments to find out what they're worth. I mean, if we did that, we'd be completely ignoring the time value of money. That's a major mistake. So what we need is a proper, rigorous way to take each of those future payments and pull them back into the present to find their equivalent value right now. This process is called discounting. And to do it, we use one of the most important formulas in all of finance. All right, let's break this formula down piece by piece. The first component is the most straightforward. It's P, which stands for payment. This is simply that constant, reoccurring cash flow that makes it an annuity. So if we're talking about a $1,500 monthly car payment, P is $1,500. If it's a $20,000 quarterly royalty payment, P is $20,000. It's the basic building block of our calculation. Now we get to the most important, and I think the most interesting variable in the whole formula, and that's R. We call it the interest rate, or more appropriately in this context, the discount rate. I want you to think of R as the mathematical representation of the time value of money itself. It is the opportunity cost we talked about. In a corporate setting, this isn't just a number you pull out of thin air. It's often tied to something called the company's weighted average cost of capital, or WACC. That's basically the average return the company needs to earn on its projects to keep its investors happy. So R is the rate we use to shrink those future payments back to what they're worth today. It's a really powerful number. And finally, the third piece of the puzzle is N, which is the number of periods. This just tells us how long the annuity lasts. How many payments are we dealing with? Is it a 60-month car loan? Then N is 60. Is it a 10-year contract with annual payments? Then N is 10. N sets the time frame for our valuation. And here's a critical point I want to drill into your heads right now. The time unit for N must match the time unit for R. If N is in months, R must be a monthly rate. We'll come back to this because it's where a lot of people make mistakes. And here it is. This is how we put it all together. This is the present value of an ordinary annuity formula. Now, please, do not just stare at this and try to memorize it without understanding it. Let's think about what it's actually doing. See that 1 plus R to the power of minus N part? That's the engine of the formula. That's the part that does the heavy lifting of discounting. It's like a time machine that tells you what $1 from the very last period is worth today. The rest of the formula is really just a brilliant piece of algebra that does this for every single payment in the stream and adds them all up for you in one clean step. It's an incredibly powerful shortcut. All right, theory is great, but let's see how this works in the real world. Let's get out of the lecture hall and step into a corporate boardroom, because the true value of these tools is only revealed when you apply them to make actual business decisions where real money is on the line. We're going to walk through a very common scenario that a financial manager would have to solve. So imagine you're in the meeting and the chief financial officer lays out this problem. This is exactly the kind of thing you'll be asked to analyze in your career. You've got two choices. Option A is a big lump sum payment today. Option B is an annuity. Now, the rookie mistake would be to just multiply $60,000 by 5 years, get $300,000, and say, oh, buying is cheaper. That is a critical error because it completely ignores the time value of money. Your job as the analyst is to make these two options truly comparable by evaluating both of them at the same exact point in time, which is right now. So how do we tackle this? We don't guess. We have a clear, systematic process. First, we'll look at the lease option and identify our variables, P, the payment, and N, the number of periods. Second, we have to choose the right discount rate, R. Again, this would likely be the company's cost of capital. Third, we take those variables and we plug them into our present value formula to get the PV of the lease. And finally, the last step is to compare that result, that present value, to the other option, the $250,000 upfront cost. This is how you make a true apples-to-apples comparison and a smart decision. Okay, let's run the numbers. Our payment, P, is $60,000 a year. The number of periods, N, is 5 years. And for this company, we're going to assume their appropriate discount rate, R, is 8% per year. So we take P, R, and N, and we plug them into our present value formula, and the answer we get is $239,558. Now that is the number that matters. That tells us what that entire 5-year stream of lease payments is actually worth in today's money. So now we can make our decision. The cost to buy the machine is a $250,000 cash outflow today. The equivalent cost of leasing it, after we discount all those future payments back to today, is only about $240,000. So, based purely on the numbers, the decision is clear. The lease is the better financial choice. It has a lower cost in today's dollars, saving the company over $10,000 in present value terms. Now, of course, a good manager would also consider other non-financial factors, but the mathematical analysis gives us a clear and powerful starting point. This is how you use math to drive business strategy. All right, we're almost there, but this is an incredibly important section. This formula is powerful, but it's only powerful if you use it correctly. A tiny mistake in your calculation can lead to a completely wrong answer, and in the real world, that could cost a company a fortune. So let's go over the most common mistakes that I see students and junior analysts make so you can make sure to avoid them. Please pay close attention here. These are the classic traps. First and foremost, mismatching R and N. I see this on exams every single semester. If you have monthly payments over a 5-year period, N is 60, not 5. And if N is 60 months, then your rate R must be a monthly rate. You have to take your annual rate and divide it by 12. You cannot mix an annual rate with monthly periods. It will give you a totally wrong answer. Second, be careful with compounding, but for our purposes, just make sure your rate period and payment period always align. Third, and this sounds so simple, but it happens, calculator errors. Fat fingering a number, messing up a parentheses. When you're using a long formula, always double check your input. And finally, a big conceptual error, misinterpreting the result. Remember, the present value is not the total cash you'll pay. In our example, the total cash paid for the lease was $300,000, but its PV, its economic cost today, was only about $240,000. Understanding that difference is what separates someone who can plug in numbers from a true financial analyst. So, we have covered a lot of ground today. We started with a very simple idea that money has a time value. And we built on it step by step until we were able to solve a complex business problem just like a professional analyst would. I want you to remember that this formula and the concepts behind it are more than just math. They are tools for clear thinking. They are a way to make sound judgments, to compare different options fairly, and to make financial decisions that you can defend. As you move forward in your studies and into your careers, your job is to master these tools not just to pass a test, but to go out and create real, tangible value in the world. Thank you for your attention today.